Quadratic functions and their graphs. First off, a quadratic function is of the form f of x equals ax squared plus bx plus c. This is standard notation. A, b, and c are real numbers. A doesn't equal 0. You're going to hear me use this word quite a bit. The word is parabola. That describes the shape of a quadratic function if you were to graph it. It's either right side up u or upside down u. You're going to find out that this, in this case, this bottom point is called the vertex. This top point is called the vertex. That's the words I'm going to be using. Vertex. And so if I were to ask you what's the vertex of this first parabola, it would be 1, negative 1. For this parabola over here on the right side, it would be negative 1, 1. Now this imaginary line that doesn't exist is called the line of symmetry, or the axis of symmetry. And it's always going to be x equals. So in this case, it's going to be x equals 1, and then for the right parabola, this one is x equals negative 1. I write that a little bit bigger so you can see it. So over here it's x equals positive 1, over here it's x equals negative 1. These are the basis of what we're going to use to graph parabolas. We're also going to be plotting additional points, but I'm just trying to go over some key information before we start doing some examples. Standard form of a quadratic function or of a parabola is f of x equals a parentheses x minus h squared plus k. Well, the vertex is always h comma k. If you notice that in standard form this is x minus h, but the vertex is a positive h, and then we have a plus k, and the vertex is a positive k. So what that means is for the h value of the vertex we're going to change the sign, and for the k value we'll keep the sign. And once again, the axis of symmetry is x equals h. And if you're wondering what axis of symmetry means, if you were to take the right side and flip over this axis, you would get the left side. The same thing with the left side. If you take the left side and flip it over, you would get the right side. That's what symmetry means. It's a mirror image. Now, if the quadratic function is of the form f of x equals ax squared plus bx plus c, we're going to use a little formula to help us find the vertex. This is the easiest way to do it. There are other ways, but we're going to use this. Negative b over 2a, and what the f of negative b over 2a means is whatever you found for the x value, you'll substitute that into the original function to find the y value of the vertex, or the h and k values. That's just a little setup. Let's continue on with our setup. How to graph a quadratic function. First thing is, we're always going to find the vertex, no matter what. Now if you look, you'll see some different scenarios I have here. Triple I, I've already mentioned it's h comma k. Now if you look at I, if it's x squared plus k, that's actually the same as x minus 0 squared plus k. So that's where the 0 comes from. We were missing the h value with the x. So that's why it's always a 0. And then for double I part, you'll notice that you have the h value but you don't have the k. So if you want to put it in, it would be plus 0, and that's why it's h comma 0. And then h comma k. And then we've already mentioned this. The next thing we'll do is we'll find the line of symmetry, which will tell us how to give us a basic idea of how the graph should be shaped. And then we'll find additional points to help us to be more accurate with the graph. Some other things you may want to know: if your a is a positive value, the parabola is going to open upward, and if it's a negative value, if a is a negative value, then it's going to open downward like that. Just some little extra things to help you out. Now I'm going to do this first example right quickly. This is the basic parabola that we're going to look at, and this is where they all come from. So f of x equals h squared. If you look at that, you don't see either an h or a k, and if you want to put those in, you would use zeros. So it would be x minus 0 squared plus 0. So in other words, once you have it in this form, the vertex will be 0, 0. And then your axis of symmetry, I may say line of symmetry, that's okay. I'll abbreviate symmetry. Your axis of symmetry is going to be x equals whatever your h value is. In this case, it's 0. And then, if you were to plot it, your vertex would be 0, 0. So that's right there at the origin. And the axis symmetry is x equals 0, and that's just the y-axis. And by the way, in case you're wondering, x equals any number, it's always a vertical line. So if it's x equals 0, it's a vertical line that crosses at x equals 0. So that's what this is. And something else to keep in mind, since the number in front of x squared is a positive, that means that the parabola is going to open upward. So we're going to find some other points just so we can be a little bit more accurate before we do anything. And so when I start making some other points, all I'm going to do is I'm just going to let x be whatever I want. So I'm just going to make a couple points, maybe 4 points. I'm going to do 2 at a time. I'm going to try x equals 1 and x equals negative 1. The reason why I'm doing that is because I know that it's going to be symmetrical about this point, or actually over this line. But I'm using numbers or x values are the same distance from 0, 0. So I'm using 1 and negative 1, and I'll probably end up using 2 and negative 2 also. You just need to use enough until you're comfortable with what it is. So if I choose or let x equals 1, then when I find f of 1, and here's the original function we're going to use, that'd be 1 squared, which is 1. So that point is 1, 1. If I find f of negative 1, that'd be negative 1 squared, which is also 1, which we would expect that since it is symmetrical. So we got negative 1, 1. So we'll plot those. 1, 1 is here, negative 1, 1 is there. And in all actuality, that's probably good enough. But let's go ahead and find a couple more. X equals 2 and x equals negative 2. So if I find f of 2 is 2 squared, which is 4. So that point is 2, 4. If I find f of negative 2, that's negative 2 squared, which is positive 4 also. So we end up with negative 2, 4. So I'm going to plot those 2 points. 2, 4 is about right there. Negative 2, 4 is about right there. Now I'm going to draw a parabola, a U shape through those. And there's a graph of the parabola f of x equals x squared. And now let's do B part. F of x equals x squared plus 3. Let's start with the vertex. Now you'll notice there's no number with the x being squared. So when that h value is missing, we'll use a 0 to represent that value, or the h value. And the 3 on the outside is your k. So it's 0, 3. Once again, if you need to see that, you can substitute in as x minus 0 squared plus 3. And then our line of symmetry, or axis symmetry, will also be x equals 0 as it was in example A, because it has the same x value. And then, well, first off, I'm going to go ahead and plot those. 0, 3 is right there, and that line of symmetry is once again the y-axis. If I said x-axis over here, I meant y-axis. And so I'm looking for a U-shape. The reason why I know it's a U-shape and not upside down U is because the number in front of the x squared is a positive. So I know it's going to go like that. But I'm going to plot a couple points. I know the general shape of it. Once again, I'm going to use some points that are the same distance from 0, 3, and are on opposite sides of 0, 3. So I'm going to use x equals 1 and x equals negative 1 again, and that will probably be enough for me because I have a general idea of how it already looks. So let's try x equals 1. So let's find f of 1. This time we're using x squared plus 3, so it'll be 1 squared plus 3. 1 squared is 1, plus 3 more is 4. So that point will be 1, 4. Then I'm going to use negative 1. Don't want to use 1 twice. I'm going to use negative 1. So I have f of negative 1, which is negative 1 squared. Make sure you use parentheses when you substitute. Negative 1 squared is positive 1. 1 plus 3 is 4. So now I have negative 1, 4. And let's plot those. 1, 4. Right 1 up 4. And then left negative 1, 4 is left 1 up 4. And once again, I have my U that I was looking for. It really isn't any more difficult than that. The only thing that may cause a little problems are the vertices, how they may look based on what you're given, but that's okay. We're just going to do a type of problem based on everything that we have. Now let's do this one. f of x equals x minus 6 squared. Let's start with the vertex. You'll notice that we have a value with the x inside being squared, so that's our h value. We won't use the negative, we always change the sign when it's inside with the x. So it's a positive 6. We don't have the outside value. If you want to, you can put it in there and be plus 0. So the vertex is 6, 0. The line of symmetry is always x equals the x value, which is 6. So as of right now, we have this. We have 6, 0 is the vertex. And then the line of symmetry is x equals 6. So I'm going to draw the vertical line. And I'm using a dotted line because this is actually an asymptote. It's not part of the graph, in case you're wondering. It's just to help us graph. I'm going to plot some additional points. I'm going to use x values that are same side of, or on opposite sides of 6. They're equidistant. So I'm going to use x equals 7 and x equals 5. So let's start with x equals 5. So when we use x equals 5, we'll find f of 5 using the original function. So we have 5 minus 6 squared, and 5 minus 6 is negative 1, and negative 1 squared is a positive 1. So that point is 5, 1. And I'm going to use x equals 7. Once again, I'm using points or x values that are on the opposite side of our vertex, in this case 6, 0. I want to use the ones that are the same distance apart. So f of 7 would be 7 minus 6 squared, which is 1 squared, which is 1 also, and that point is 7, 1. So I'm going to plot those 2 points. 5, 1 is right there, 7, 1 is right there. So what we would expect, because once again, the number in front of the x squared term is a positive value, so that's why it's going to go upward. So no surprises. Just drawing our U shape of parabola. Let's do D part. As you can tell, we're expanding upon our information that's given. We're increasing our knowledge. You'll notice this time that we have an h and a k that's not 0. They're actually given. The h value is a positive because we always change the sign when it's with the x, and we always keep the sign on the outside for the k value. So this is h and this whole thing is k, so it's a negative 4. It's change sign, keep sign. 2, negative 4. And then our line of symmetry, or axis of symmetry, is always x equals the x value, which is 2. I'm going to go ahead and plot those using this grid. So we got 2, 4, or 2, negative 4 I should say, because this is what we're using. 2, negative 4 is right here. That's our vertex. If you want to, you can put a V there. And then we're going to draw the axis of symmetry, which is x equals 2. And then, once again, I'm going to plot a couple points. You can use as many as you want. I'm feeling pretty good about myself. So I'm going to use, since this is our vertex, I'm going to use the x value of 3 and 1. So, here I go. I'm going to use x equals 1, x equals 3. I'm going to substitute those into the original problem. So if I find f of 1, I have 3, 1 minus 2 squared, minus 4. I'm going to mark that out because I'm going to need some more space. Equals 3. 1 minus 2 is negative 1 squared minus 4. Square is negative 1, and I get positive 1 minus 4. And 3 minus 4 is negative 1. So that point is 1, negative 1. 1, negative 1. And then I said I was going to use x equals 3, so I'm going to be a man of my word. I'm going to use x equals 3 and substitute that to the original function. So we have f of 3 equals 3, parentheses, 3 minus 2 squared minus 4. Do parentheses first, you get 1 square. 1 squared is 1. And 3 times 1 is 3. And 3 minus 4 is negative 1. So we end up with 3, negative 1. So I got these 2 points to plot. 1, negative 1. And 3, negative 1. Let's plot those. 1 comma negative 1 is right here. 3 comma negative 1 is right there. I know since the 3 is a positive value, it's going to go upward, U-shape. That's what I'm doing. I may need to use a couple more points, but that's fine. We get the basic idea of what's going on. You'll notice the 3 does something to these y values that we found. It makes them bigger, quicker. So in other words, it actually makes it more narrow when we actually graph it instead of being wide like that. Now for E part, you'll notice something slightly different. You'll notice there's a negative sign in front. As soon as you see that, the x squared term is negative, that means that their graph is going to be upside down U. Just keep that in mind. So start the vertex. We have x plus 4 inside squared, which means that the h value is going to be not the plus 4 because we changed the sign, negative 4. Then our k value is at plus 1 because we keep that sign. And then our line of symmetry, or axis of symmetry, is x equals negative 4. So as of right now, we have the vertex being negative 4 comma 1, and the line of symmetry is x equals negative 4. And then we know it's going to be upside down, an upside down U, so it's going to go downward. So let's find a couple points to help us realize what it actually is. So once again, I'm at negative 4 comma 1 is the vertex. So my x values I'm going to use are x equals negative 5 and x equals negative 3. And then you can keep on going if you want to. Negative 6 and negative 2, negative 7, negative 1, so on and so on. I'm going to use negative 5 and negative 3. So I'm using x equals negative 5. I'm going to substitute that into the original function. So I have negative, parentheses, negative 5 plus 4 squared plus 1. That gives us negative, do the parentheses first, negative 1 squared plus 1. Stay with the parentheses, negative 1 squared is a positive 1 plus 1, and then negative 1 plus 1 gives us 0. So that point is negative 5 comma 0. And now, what let's do, as we said we're going to use x equals negative 3. Let me straighten my paper up a little bit. Trying to get organized here. Kind of hard to do. X equals negative 3. So I'm going to substitute that in. Alpha of negative 3 would be negative, parentheses, negative 3 plus 4 squared plus 1 equals negative. Then negative 3 plus 4 is 1 squared plus 1. Then we do the exponent first. We get 1 squared is 1. So we got negative 1 plus 1, which is 0. Hopefully you start to realize that based on what we're using, that once we find the y value for x equals negative 5, we also know the y value for x equals negative 3. Just keep that in mind. And in fact, let me show you something. If I were to use x equals negative 6, that means I would know what the y value is for x equals negative 2 once I find that. So let's do that. So if I do x equals negative 6 and x equals negative 2, I'm going to get the same answer for both of those. So I'm just going to substitute x equals negative 6 into the original function. So substitute in. I'm going to try to do this one kind of quickly. I'm doing parentheses first, then the exponent, then I add those, and I get negative 6 comma negative 3, which means I also get negative 2 comma negative 3. If you substitute that negative 2 in, instead of negative 6, you get negative 2 plus 4 is a positive 2. When you square a positive, you still get that 4, and the negative 4 plus 1 is negative 3. So, I actually have 4 points I can use now. Negative 5 is 0. Negative 3 is 0. Negative 6, negative 3. Let me move this up so you can see it. And then negative 2, negative 3. And the reason why, once I find one y value, I know the associated y value on the other side of the line of symmetry, because this is the line of symmetry. So that point flips over to that point. That point flips over x equals negative 4 to that point. And I connect the dots. upside down U, which is what I expected to have. Now look at F part. I'm going to try to use that last information we just discovered to help us with the points. But here's the thing with this one. First off, I see a positive 2, which tells me in front of the x squared, which tells me right side up U. It's not in correct form, so I'm going to use negative b over 2a comma alpha of negative b over 2a to find the vertex. So in fact, I like to look at it like this. I'm going to find x equals negative b over 2a first, or I should be using h. So h equals negative b over 2a. This is our a, 2 is a, b is negative a, and c is 5. So I'm going to substitute negative 8 for the b. Notice the minus sign and then the b, and then a is 2. And so I end up finding that h is a negative is a positive 8. 2 times 2 is 4. So h is 2. Now to find k is nothing but alpha of 2. That's all that part there means is. Once you find the h value, you're going to find alpha of 2 by substituting that in to the original equation. So I'm going to come down here and write it out. 2 parentheses 2 squared minus 8 times 2 plus 5. If you have a calculator, this could be a whole lot quicker, but let's go ahead and do it step by step. 2 squared is 4, 4 times 2 is 8, 8 minus 16 plus 5, 8 minus 16 is negative 8, negative 8 plus 5 is a negative 3. That tells me that the vertex is 2 comma negative 3, and then our axis of symmetry is x equals 2. So let's go ahead and plot those. 2 comma negative 3 is our vertex, is right there, and then h equals 2 or x equals 2 is the line of symmetry, and I know it opens upward. So I'm going to use, watch this, I'm going to use 0 and 1 to show you how I can get 4 points just by using those two. There's my vertex information once again. And once again, I'm going to be using 0 and 1. My vertex is 2. So I'm going to use points in front of it, x equals 0. Substitute that into the original problem. 2, 0 squared minus 8 times 0, and then plus 5. Good thing about 0 is these all end up being 0. 0 squared is 0, 0 times 2 is 0, 8 times 0 is 0, 0 plus 5 is 5. So we have that point 0 comma 5. Let's go ahead and substitute x equals 1. So we have f of 1 equals 2 parentheses 1 squared minus 8 times 1 plus 5. So we have 1 squared is 1 times 2 is 2. 8 times 1 is 8 plus 5. 2 minus 8 is negative 6 plus 5 is negative 1. So we have that point 1 comma 5. Now let me show you something. My bad. That make any sense, did it? Because we got negative 1. It's 1 comma negative 1. That makes more sense, doesn't it? So we got 0 comma 5 and 1 comma negative 1. Let's plot those. 0, 5 is right here. And then 1, negative 1 is right here. Watch this. Since this point is on this side of the line of symmetry, when I flip it over, it's going to be right here. When I flip this point over the line of symmetry, it's 2 away from that line, so it's going to be 2 away on the other side. How you like that? So when I found 2 points, I actually ended up finding 4 points. And the more points I have, the more accurate the graph is going to be. Pretty cool, huh? You may not think so, but I do. That's all that matters. Let's do one more. Once again, it's not in the form that we need it to be, where we can just go ahead and identify the h and the k. So what that means is that we're going to use that same formula, that negative b over 2a. Here's the way I like to use it. H equals negative b over 2a. A, B, C. Now a is in front of the x squared. If you see a minus sign, that's a negative 1. b is in front of the x, and that's not a 2, it's actually negative 2. So we end up with a negative 2 is a positive 2, and 2 times negative 1 is negative 2, which means our h value is 1. And to find k, we'll find f of 1. So that'll be negative 1 squared minus 2 times 1 minus 7. 1 squared is 1, which gives us a negative 1 minus 2 minus 7. Negative 3 minus 7 is negative 10. So our vertex is 1 comma negative 10. Our line of symmetry is x equals 1. So we have 1 comma negative 10. My grid goes off the page, so I'm going to extend that. 7, 8, 9, 10. So we got 1 comma negative 10, which is right there. Here, and the line of symmetry is x equals 1. Something else. This goes up to, this a is a negative value, which means our parabola is going to be upside down. And so I need to find some points. Once again, I'm going to use what I've been doing. This time, just to change it up a little bit, I'm going to use x equals 2 and x equals 3 as my additional x values for additional points. So let's do x equals 2. You can use what you want, but I have to use the ones that are really close to our line of symmetry. So we have f of 2, which is negative 2 squared minus 2 times 2 minus 7. Square first, we get negative 4 minus 7. Negative 4 minus 4 is negative 8. Negative 8 minus 7 is negative 15. So that point is 2 comma negative 15. I'm going to go ahead and find x equals 3. So f of 3 equals negative 3 squared minus 2 times 3 minus 7. 3 squared is 9. Don't lose that minus sign. Minus 6 minus 7. Some of you were wondering, I thought when you square, you always get a positive. Well, that's true, but that minus sign is on the outside. Use parentheses, you won't make the mistake. Negative 9 minus 6 is negative 15. Negative 15 minus 7 is negative 22. So that point is x equals 3. And we got a y value of negative 22. Which means I got to extend this a whole bunch further down. So 10, let's go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 11, 12, 13, 14, 15. So, we got 2 comma negative 15 is about right here. And 3 comma negative 22 is about right there. Since that's on this side of the line of symmetry, when I flip it over, it's going to be over here. That one, I'll flip it over. It's probably more like over here a little bit. So mark that one out. So that's going to be actually over here. And so it goes sharply downward. Make that U. That's just terrible, but you get the idea. Let's get a look, just a little crooked in there, because that one should have been actually right there. So it should have been like this. How you like that for messing one up? But that's okay. Since the 2 was 1 over from 1, then this point, the one symmetrical to it, should have been at 0. But that's okay. If this were extended more, you would have been able to see that. So make sure you got it going to the right points. And that's how you graph a parabola. You know, same process, just make sure you get all the math correct. Now let's do E part. This one may get a little messy. Let's hope not. First thing I noticed is that the x squared term is a negative, which tells me that it opens downward. It's the first thing. And now, since it's not in the x minus h squared plus k form, I'm going to use a vertex formula. I'm going to use h equals negative b over 2a. So you can write it like this. I have to rewrite it without the variables and use empty parentheses. A is going to be negative 1, b is going to be negative 2, and c is going to be negative 7. Since b is negative 2, it's going to go there, and a is negative 1, it goes in the denominator. And so we do the math, and we get negative 2 is a positive 2 over negative 2, and that's a negative 1. Now we're going to find the k value of the vertex by finding f of negative 1. So that's going to be negative 1 squared minus 2 times negative 1 minus 7. do the math correctly. Exponents first, that gives you a positive 1. Negative 2 times negative 1 is a positive 2, minus 7. The negative 1 plus 2 is 1, and 1 minus 7 is negative 6. So our vertex is negative 1 comma negative 6. Now the axis of symmetry will be x equals negative 1. So negative 1, negative 6 is down here. Let me move this up so you can see it. And that's our vertex, negative 1, negative 6. And our line of symmetry is x equals negative 1. I'm going to extend a little bit more. Here's why I'm extending it a little bit more, because I know the graph is going to go downward, so I'm going to have to extend this y-axis also. I don't know how much, but we'll find out. So let's just use a couple points. I'm going to use x equals 0, and then we use x equals 1. So if I use x equals 0, I'll substitute that back in the original equation, original function. So f of 0 will be negative 0 squared minus 2 times 0 minus 7. 0 squared is 0, 2 times 0 is 0, and 0 minus 7 is negative 7. So I have a point 0 comma negative 7. So if I go ahead and plot that, that would be right here, 0 comma negative 7. If I plot x equals 1, I find f of 1, or substitute it, or find x equals 1. I may say plot. I'll substitute in original function. 1 squared is 1, makes that negative 1, minus 2, minus 7. Negative 1 minus 2 is negative 3, negative 3 minus 7 is negative 10. So that point is 1 comma negative 10. So I got 1, then 7, 8, 9, 10. 1, negative 10 is right there. Now watch this. If I take that point and flip it over the line of symmetry, this is going to be another point on the parabola. If I take this point and flip it over, that's going to be there, approximately. And then I connect the dots, and I'll see an upside down U form. That's alright. I'm going to do the same problem, but this time I'm going to use something really nice if you happen to have it. And that is called the graphing calculator. So I'm going to show you how you do it on the graphing calculator. I don't know if you can see that or not, because it's bright based on the calculator, but that's okay. I'm going to turn it on. I'm going to hit y equals. Now I've already got mine tapped in there. I'm going to clear it out so I can tap it in there again. And you'll see that we're going to type in negative x squared minus 2x minus 7. Use this as your negative, use that as your subtraction. Keep that in mind. So I'm going to hit the negative first. And then we'll hit the x, and then I can hit that for square, or you can hit that with a 2 after it. And then minus 2x. Notice the difference in the size of the negative and the subtraction. Then minus 7. Then I'm going to graph it. Now what you're going to see is you're going to see that upside down U. One thing you can do to help you with the points is hit second table. And you should start seeing some of the same points that I use. Negative 2, negative 7 was the vertex. Negative 1, negative 7. Negative 1, negative 6, I mean, is the vertex. Make sure you're using the right one. And you'll see that I also use 0 comma negative 7. And you also see that I use 1 comma negative 10. Here's the interesting thing though. We know that a vertex is negative 1, negative 6. If you start looking, you see that 0, negative 7. That's on the right side of negative 1. The left side, you'll see the negative 2, negative 7. See that? And then I also used 1 comma negative 10, but then I also used negative 3, negative 10. In fact, you could actually use the graphing calculator to help you with the vertex, if they're nice numbers, that is. If they're decimals or fractions, not so much. But notice, you see the negative 3, negative 10, 1, negative 10. You'll see the negative 2, negative 7, 0, negative 7. But then you see the negative 1, negative 6, and you don't see another. That should kind of tell you that that's your vertex, because it doesn't have another x value that has a corresponding y value of negative 6. So, it doesn't always work, but hey, maybe it will. But that's just a little, something to help you with your graphing if you happen to have your graphing calculator. I do know other tricks, and if you want to know, if you're in my class, ask me.